Hi, student. In this video, we are going to learn about the basic concept of fundamental of the formal language and automata theory. So your subject name is the formal language and automata theory. Paper code is CS403. Myself, Dr. Rampal Singh, Associate Professor of Computer Science and Engineering Department of JS College of. So prerequisite means when you are going to learn the topics. When you are going to learn the topic there, you have to know that what is the prerequisite for that. So before that, we have to require some digital logic concept, just like the electronic concept. What are the circuits? What are the gates? Computer organization, like sequential circuits, will be there. Combinational circuit will be there. So this type of concept will be required here. And the computer fundamentals means how we can write the program there. What are different type of terms like array? Okay. So what is the course outcome? When you complete this course, what you are able to know that? You are able to know that what is the machine, how we can classify the machine there, and after that we can understand what is the sequential circuit and how we can convert into the digital system there. Then we are also able to know that grammar means what are the language accepted by the machine, so how we can write the grammar for that. Okay. Also you can get the idea about the Turing machine. That machine is the same capability as your computer is. And also you are able to know that when you are going to implement any machine, so what are the limitation, what are the power, and what are the computability decision, you are able to know it. These are the COPO mapping of your course with the program outcomes. Now your subject have the 5 modules. Okay. So first one fundamental, second one finite automata theory with output is the module 2, regular languages, grammar formalization, and Turing machine. So module 1 we are going to learn this part. Okay. So what is the formal language and automata theory is? The definition. So we have to know that what is the meaning of the formal language and automata theory. Okay. What is the idea about this? So you can see here. So if I say that the machine, then I can consider these 3 parts. I can give one input, and second one we can produce the output. I can say this is the I and this is the your O. So when I want to define the formal language automata theory part there, mainly automata. So what I can say that your automata machine have the inputs, then it have the output there. Okay, just like the example of the vending machine, we are giving the different type of coin, and according to that we are getting the product. So automata, how we can define that? Automata, we can say that it have the set of input, because 1 rupees, 2 rupees, 3 rupees, this coin will be there, and it have the set of outputs, like I can get the chocolate, I can get the perks, I can get the holdings, like that, based on the input. So your automata must have the 3 parts. One is the set of inputs, and second one is the set of output, and there is some things which will be processed, like the computation, means processing power will be there. So automata also have the same thing. It have the input, it have the your output, it have the your set of states, and connection between one state to the other states will be also there. As for example, suppose I am giving the some coin. It may be possible the coin is not valid. If I give the correct coin, then it will go from one state to the next state. So this type of things are saying the relation between the states are there. Okay. So when I say automata theory, so I can say that automata means the one type of system, one type of machine that will be perform the specific tasks without direct intervention of the human being there. Our task is that we can give the input, based on input it processes, and it will give the output there. Okay. Now formal language means suppose some natural languages are there. Okay. So we have to represent this natural language in form of the machine. So whatever the language we have to represent that language in form of the machine. How we can do it? Later on, we can know that by taking the help of the tuple, we are able to do it. Okay. So for the time being, concept is consider that the how we can implement the concept of formal language. Some natural languages are there to represent this natural language in mathematical format. We can say this is your formal language there. And automata 3, I already mentioned that it is the one system, one automation that will be perform the task in a specific manner without the direct participation of human being there. Okay, so this is the definition we can say that. Meaning means already explained that requirement, why we are going for this one. Suppose some natural languages are there because we are seeing machine learnings are there, many algorithms are present there. Suppose that some natural languages are there. If we are able to formulate these natural language in form of the your uh, mathematical model, so easily we can represent the things in program. We know that if anything is represent in mathematical model, systematic way, we are able to implement this one in form of the your program there. So that is the requirement. Means here it provides the idea, it provides the confidence how the machine will be there, and we can write the languages for that. Later on, we can see that also it is helpful in the 6th semester compiler design. How the lexical analysis in compiler we can do it. Okay. So now the automata part is here. What is the how the automata looks like there? So you can see this figure. I can draw it. Here the input is there. You can see like a 0, 1, like that. These are the input. And here states will be there. Okay. So it is the saying that the automata one way finite tape broken into cell. These are the tape, input tape, these are the broken, these are the input A, 0, 1, these are the input. And this is one way reading, means I can read this one, after that I can read this one, then I can read this one. Okay. Finite control means this is known as a finite control. Finite number of states means I already mentioned just like the example of vending machine, we have the lots of states there. Transition rule between them means how I can move from one state to other state. Suppose in case of vending machine, if I rupees is correct, I can go to the next step to checking whether the product is available or not. If it is available, then I can go to the final state. So transition between state will be there. Okay. And it is saying that the program containing the position of the read head, current symbol being scanned, and the current state. So when you want to move from one state to other state, what I can say? We have to present one state, taking the input, we can go to the next state. Just like I have 1 rupees coin, and just one state is there in beginning state, just giving the 1 rupees coin. If it is valid, I can go to the next state. So that is the reason it is saying that if you know that the automata is saying that for present state Q, taking the input I can go to the again the one state Q. Okay. So 2 rupees coin, so 2 rupees coin. At the beginning, I have given it, verify it is correct. So next state is that check the product like this. Okay. So sometimes they ask that some input string will be given there, whether this inputting string is accepted or not. So we have to know that. Okay. Now already I have given the definition of the formal language, so you can get the idea from this part there. Formal language is a set of string of symbol drawn from the finite alphabet. Okay. Also, we are able to represent these natural languages in form of your machine, represent in form of mathematical model, so it is useful. And we can also take the help of your different type of machine that will be accept the regular expression or context free grammar there. Okay, so later on we are going to learn that what is regular expression, what is context free grammar. Now here we are going for the definition of the finite automata. Finite automata are two types. One is known as the DFA and second one is known as the NDFA. DFA means deterministic finite automata, or NDFA means non-deterministic finite automata. Okay. So as I already mentioned, if you remember this previous example, The automata mainly have the input, finite states, outputs, combination between set of states. Okay. And one more thing, uh, from where I can start. Initial state must be there, means where I can insert the query, and from where I can get the product there. So final and the initial state, these two parts also present in case of automata there. Now you can see that capital Q, it is a combination of 5 tuple. Tuple means order pair. Just like the graph, we use the order pair like VE, V comma E. Meaning of this is what? Meaning of this one is saying that we can use the vertex and edges. So similarly here, when you represent the automata, DFA first will become set of states. So because order pair means it will be some order. We are not able to write the input alphabet first, this one first, and this one here. No, order pair must be there. Okay. So finite set of state, and this is the input alphabet, means many inputs are possible. I have given the example like 2 rupees, 5 rupees, 10 rupees coin, and one initial state means from where I can start, and also the final states there. And this is a transition. I already mentioned the transition. From one state, taking the input, I can go to the next state. Okay. So this is the meaning of the deterministic. Deterministic is saying that, just I'm going to clear the idea. From, keep in mind every student, those who are listening it, from one state, taking the same input, I can go to the single state. This part is known as the DFA, deterministic. But for the same input, if more than one states are available, then it is your NDFA. Suppose in case of vending machine, I know that if I give the 2 rupees, I can get only one product they have mentioned. Suppose if I giving the 2 rupees, more than one product is available for 2 rupees. So we are in dilemma which product I can choose. But if they will specify for 2 rupees only single product, so there is no dilemma. We know that I will give 2 rupees, I can get this product. But if more than one product is available, then it is in we are in dilemma there. So same thing is applicable in the DFA or NDFA. DFA is saying that for the same input from one state, I can go to only one state. But NDFA is saying from the one state, taking the same input, keep in mind, same input, we can go to the more than one state. That is the NDFA. Now you can see this figure there. So in this figure, we can see whether it is DFA or NDFA. Okay. So now you can see same input means here 1. By taking the 1 from Q0, we are only in a single state because I can see I can go only one state. So this is your DFA there. Because if I take the 0, I can go to the other state. Okay. Yes, only one movement for the one input. You can see only one movement for one movement for one input. Okay, so that is your DFA there. And why what is doubles, concentric circle, and what is the arrow? Arrow is saying that it is the initial state, and concentric is saying that it is a final state. Okay, so this is an example of transition diagram. Transition diagram have state, taking the one input, it will be the same state. Q0, taking the 0, it can move to the Q1 there. So that is the function which already we have mapped. Set of state input, we can go to the next setup. So this is the DFA, and this way we can represent this one. Write the 2 states and 2 input. Here only 2 inputs are there, 1 and 0. So Q0 taking the 0, where we are going? Q0 taking the 0, we are going to Q1. So I can write the Q1. Q0 taking the 1, where we are going? Same, Q0. So in this way we can write the table, and this table name is the transition table. Okay. Now sometimes they ask that whether this string is accepted by your automata or not. Okay. So before that, we can see in case of NDFA, what is the situation? So situation like this. NDFA, I'm saying that again. So for the same input 1, 1, I can go to the 2 state. One is the same and one to the Q1 there. So we are in dilemma. If I take one, where I can go? I can go to the second Q0, or I can go to the Q1. So keep in mind that there is one difference between NDFA or DFA, is that DFA is that for the same input only one state, and NDFA is for the same input more than one state. So now here we are going to know that how the automata accept the string. Okay, suppose this is given here, and they ask that whether this automata accept this string or not. So string acceptability is saying that starting from the initial state, after consuming this string, if you reach to the final state, then I can say that this string is acceptable. Okay, so I can check it starting from Q0. Okay, we are taking the 0, where I can go Q1. Okay, after Q1, Q0, you can see here this figure is saying the transition diagram. Okay, Q0011. Okay, so now question is that here we have to implement the idea. So simple way we can go in this way. You can see Q0. I am just writing in this way. It is better for you. This way 0, 1, 1. Okay, this is a 0, 1, 1. So now you can check Q0 taking the 0 where it is going Q1. So it will be go to the Q1, and now the input will be the 1, 1. Okay. After that, Q1, 1, same state will be there. So Q1, 1. You can check here. Q1 taking 1, Q1 taking 1, same state, same state. So Q1. Again Q1, 1 taking the same state. So after that you can see that string is null. Nothing is there. So what I said that starting from initial state, consuming all the string, if I reach to the final state, and final state represented by double concentric circle or concentric circle there. So here I can see this is not the final state. So what I can say that this string is not acceptable. But if I write in this way, suppose. So after this one, I can get the 0 in Q1, and from Q1 taking the 0, I can go to the Q0. Okay. So if I go to the Q0, Q0 is the final state. So this string 0, 1, 1, 0 is acceptable, but string 0, 1, 1 is not acceptable there. Okay. So keep in mind that starting from the initial state, consuming all the string, if I reach to the final state, then I can say string is acceptable by the final purpose. Thank you. And I hope that this will be clear your doubt regarding the regarding the first topic of the formal language automata.